In the previous video, we defined rotational inertia or rotational mass as the integral of r squared dm. In this video, we apply the concept of rotational inertia to a thin ring of mass m and radius r rotating around its symmetry axis to get I equal to mr squared. We also integrate r squared dm over a uniform disk or cylinder of radius r and mass m around its axis and get the familiar formula I equal to 1/2 mr squared. For this ring, if it rotates around its central axis like that, around this, what is the rotational inertia? So suppose it has a mass m and radius r. So let's say this is the ring and rotating around this axis perpendicular to the face, and it has mass m and radius r. If you add all the mr squared, what do you get? Let's say I is integral of r squared dm. Let's take dm like that. What is the distance? R. So R for all of them is capital R, right? And it's a constant. So it becomes R squared comes out. I becomes R squared integral dm. What is integral dm? Total mass. So I becomes m r squared. This is for a ring rotating around its axis of symmetry. Right? So what about if you have a cylinder? Now we have this cylinder or a disk. It is like this, rotating around its axis, going through this. So for a disk or our cylinder, see the distance of different parts to the axis of rotation, which is going through the center perpendicular like that, is different. It is not like that simple that can come out. So we have to do actual integration. So what can we do? We can break it into rings, right? Let's take a ring and radius r goes around like that, and thickness dr. Two concentric circles, one is at distance r, one is at distance r plus dr. Right? And that, if dr is very small, acts like a ring. Right? For that, I can say inertia of that is its mass times its radius squared. Right? Because it looks like a ring. So if this has dm and has radius r, I can say di for that part is r squared times dm. And then add all the contributions. So what is dm in terms of the total mass? Can you say what total the dm is in terms of total mass?
dm over dr equals m over r.
That, where does it come from? Is it the area? Are you talking about area?
I'm thinking because like, doesn't the ratio always have to be the same? No, it doesn't.
No, you see, if you have dr here and you have dr here, it has more mass if you are further away, right? With the same dr. That's you have 1 millimeter here and 1 millimeter here. Which then do they have the same mass? No. So you need to be a bit more careful. It is not proportional to the dr. It is proportional to the area in that ring, the face of the ring, right? The area in here, right?
In between that circle?
These two circles, yes. The area between these two circles and the area of the whole thing. That's that fraction of the mass it has, right? You can say dm over total mass is equal to the area of this, dA, over total area, which is pi r squared, right? So what is this dA?
It's the area, the circle you made.
Yeah, area of this circle minus the area of this circle, right? The area between them.
Yeah.
If you have area equal to pi r squared, and then if you take derivative of area with respect to r, is how much area increases if you increase the radius by r, is what? dA over dr.
Circumference.
2 pi r, really? You see? 2 pi r, if you multiply by dr, dA becomes 2 pi r dr. That's the same as cutting this and open it up. You get a rectangle. One side is dr, the other side is circumference, 2 pi r, right? So dA is 2 pi r dr, right? And A is what? A is pi r squared, r capital R. So an A is not, this one was area of this, but the area of the whole thing is pi r squared. Let me call this A prime so that you don't mix it with that one. Right? All right, so this is the area, this is the A. So dm over m is that dm 2 pi r dr divided by pi r squared. Right? And then pi cancels out. And dm becomes m times 2mr dr over r squared. Right? So dm becomes 2m r dr over r squared. This is the m. So I is the integral of r squared dm, and dm is this. So it becomes 2mr dr over r squared. Right? And what is the extension of r? And if I want to add all the pieces here, r goes from where to where? Right.
0 to r.
From 0 to r, 0 to capital R. Right? To cover the whole mass. So now I becomes 2m over r squared is constant, comes out 2m over r squared. Then integral of r squared and r becomes r cubed dr. And from 0 to r. What is this integral?
R to the 4 over 4.
1 over 4 r to the 4. So let's put that in. 2m over r squared, 1/4 r to the 4. And see r squared cancels. One of the two cancel. I becomes 1/2 the mass times r squared. And this is another formula you have in your book. I hope you enjoyed this video, and thanks for watching.